Good day, guys. This is your tutor engineer once again. I'm back with you on the question on financial maths. This is a grade 12 question. So let's start with it. 6.1 says 12,000 was invested in a fund that paid interest rate of M% per annum compounded quarterly. After 24 months, the value of the investment was 13,000. So determine the value of M. So this should be a simple calculation. So basically we're going to be using this formula here. So that A is equal to P bracket 1 plus I to the power N. So you realize that the value of A is this one. That's what the investment is going to be. And then in the future. And then this is how much was invested. So that's going to be our P. And then our M, since it's compounded quarterly, going to be dividing our M by 4. So this is our I actually. And then our N is 24 months. So just be careful here. You need to convert this 24 months. So in 24 months, how many quarters have you got in 24 months? So there are 8 quarters in 24 months. So our N is going to be 24 divided by a quarter is like 3 months divided by 3. So that will give us 8. So basically that will give us 8. That's going to be our N there. So let's just plug in the numbers. That's 13,459. The P is 12,000. 1 plus the M compounded quarterly, so it divided by 4. And then the N is 8. So let's go on. And then here we'll divide it by 12,000 both sides, including this side. And then we'll remain with 134,559 divided by 12,000. This side will have 1 plus M over 4 to the power 8. So to get rid of the 8, I'll multiply both sides, or I'll raise the exponent of 1 over 8 on both sides of the equation, so that I'll remain with 1 plus. I'll continue from here. So on the left hand side, I'll still have 134,559 divided by 12,000 to the power 1 over 8 is equal to 1 plus M over 4. And then I'll start subtracting 1. This side and this side I'll subtract 1. And then I'll have, let's just arrange it properly. This side 1 over 8, so here is a minus 1. Then I'll have M over 4 on the right hand side. Then I can just multiply both sides by 4 basically. So that 4 is not the exponent, it's multiplying actually there. So I'll have M on the right hand side is equal to, let me just put all of that number on the calculator. So that's 134,559 divided by 12,000, exponent 1 over 8 minus 1, all of it times 4 gives us 0,0578. Therefore we can say M is 5,78%. So we'll move on to the next question. On the 31st of January 2022, Tino deposited 1,000 rands into an account that paid an interest rate 7.5% compounded monthly. He continued depositing 1,000 at the last day of every month. He will make the last payment on the 31st of December 2022. Will Tino have sufficient funds in the account on the 1st of January 2023 to buy a computer which costs 13,000? Justify your answer by means of an appropriate calculation. So basically, Tino is trying to save to buy the computer at the end of the year, which cost 13,000. So because Tino is trying to save, we're going to be using this formula here for the future value, which is F is equal to X, which is going to be the monthly contributions from Tino's side. That's 1 plus I exponent n minus 1. So I close the bracket, divided by I. So this is the formula we're going to be using. So we're going to calculate the F, the future value. If the future value is 13,000 or more, then we'll conclude that he'll have enough. If it's less than that, then Tino won't have enough. So let's just work it out. So F is going to be equal to X is 1,000 rands. So that one is straightforward. Then that's 1 plus I, it's 7.5%, so that's going to be 0.075. We'll divide it by compounded monthly by 12. Then we close this bracket. Our n will have to be 12 months since it's starting in January, and then we're trying to calculate the money at the end of December. So that will be 12 months. So that will be our n. So that's exponent 12 minus 1 from the equation. Then you divide this by the I, which is 0.075 divided by 12. Okay, so we can just from here just do one calculation on the calculator. So that's going to be 0.075. Okay, I'm just going to punch all those numbers that you see. So that's all divided by 0.075 divided by 12. So I'm getting that the future value by the end of the year, he'll be having 12,421.2 rands. So as you might notice, this is way less than 13,000. So he won't have enough. So you need to step up and save more than 1,000 rands, then he will make it at the end of the year. Now let's do 6.3, the last question. Thabo plans to buy a car that costs 250,000. He will pay a deposit of 15% and take out a loan for the balance. The interest of the loan is 13% per annum, compounded monthly. So the first question is calculate the value of the loan. Calculate the value of the loan. So you'll remember that this is the deposit that Thabo will be paying out. So basically we can say the deposit in terms of rands would be 250,000 times 0.15%. So this is the deposit. How much is it gonna give us? 250,000 times 0.15. So it gives us 37500 rands. So the value of the loan would have been now the total loan 250,000 minus the deposit that Thabo would have paid out. So the value of the loan is now going to be sitting at 212,500 immediately after Thabo pays out the deposit. This will be the value of the loan. So that's it for the first part of 6.3. The last part of 6.3, the first payment will be made 6 months after the loan has been granted. So this is important. So he's not paying immediately after he took out the loan. He'll make the payment 6 months later. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. So 6 years. So 6 years, since that is compounded monthly, that would be n is 6 times 12. How much will that be? That will be 72. 72 payments. That should have been done in 6 years. But the first 6 months is not paying. So we'll have to subtract. So if you were to picture this for the first 6 months, I'm just gonna, this will be month 1, month 2, month 3, month 4, month 5, and month 6. He's not paying anything here and there and there and there and there. And then after 6 months, then you start paying. So it means when you're going to calculate the monthly installment, we have to find the present value just before, a month just before he makes his first payment. So this is what you're going to be calculating going forward. So from month number 6 to going on up until the whole of 6 years, he would start paying an X amount. So that's the X that you need to work out. Now, since this is the loan, we're going to be using this formula of the present value. One plus I exponent minus n close brackets all divided by I. Okay, you might have realized that he's not paying for the first 6 months, so we're going to be calculating the present value just here, right? So the present value, since the present value will be at month number 5, just prior to the first payment, that means the n will change now. We're basically saying n is equal to 72 minus 5, right? The first 5 months are not accounted for. You start paying on the 6th month. That means the first 5 months, because you only pay at the end of the month, which he paid on the end of the 6th month. So basically our n is going to be 72 minus 5. How much will that be? That puts us at 67 payments that he will be making. He'll be making 67 X payments. But now we still have to find the present value at month number 5. We know the value here of the loan. We did calculate it from the previous question. It was sitting at 212,500. But in spite of him not paying, this value would still have to be accumulating to a certain amount. So it's going to be going up until month number 5 to a certain amount. That's the money, that's the amount you need to work out there from 0 to month number 5. So we're going to be calculating it from this side here. So that will be 212,500, which will be accumulating over the period of 5 months. So what is the interest rate again? So the interest rate is 13% compounded monthly. So it will be accumulating at 13%. Since you compound it monthly, divided by 12, and then that is over the duration of 5 months. So just say here exponent 5. So that will be the present value at month number 5, and then afterwards he will start paying an X amount. That's 1 minus 1 plus same interest rate divided by 12 for the rest of the 6 years, which will be 67 payments. So that's minus 67, just like that. Then I'll close in the bracket from here, and then I'll divide it by 0.13 divided by 12. Now it's a matter of just solving for x, just basic mathematics. So this will still be 212,500, 1 plus, that's the thing about financial maths. So I'll take this to that side, so it's dividing this side is going to come and it will multiply, and then this whole bracket here. Okay, I'll work it out on the very next example. I'll be remaining with that whole bracket. That's 1 plus 0.13 divided by 12 exponent minus 67. And then from here, I'll start dividing by this bracket. Including this side. And then I'll work out the x. So just have to be patient here. There's a lot of room to make mistakes when it comes to financial maths, but we're not going to do that today because we're going to be very careful. Okay, we are almost there. That's 1 plus finally, 13 divided by 12. Okay, there you go. I'm getting 4724,96. So this is the amount that he'll be contributing towards his loan for the rest of 6 years. So that's it. Hopefully you understood. If you like the lesson, please hit the like button and consider subscribing.